At the American Geophysical Union Fall Meeting, the Earth and space science community gathers both in New Orleans and online to network and connect and exchange the latest thinking about our world and beyond. The Fall Meeting program explores a wide range of topics such as climate change, solution science, equity in the research community, and much more. Since 1919, AGU's members have explored the deepest oceans and the furthest planets, and AGU TV is here to cover it all. Welcome back to another exciting episode of AGU TV. The theme of the meeting today is climate change and the onset of the Anthropocene. This is undoubtedly on everyone's minds as we enter a new age of human-caused impact on our Earth systems. But fortunately, the bright minds of AGU's members are generating new research and new ideas on how we as a species can help tackle this great challenge. On today's episode, Nicandra Norwood returns from the Convention Center in New Orleans. So Nicandra, who will be joining you today?
Thanks, Atria. On today's episode of AGU TV, we're joined by AGU President-Elect Lisa Grimlick, who gives us a little introduction into the field of paleoclimatology. Christine Shields on the Community Earth Systems Model and climate modeling. Richard Moss on his career working at the crossover between policy and science, and Joe Hamman on his work at the nonprofit CarbonPlan.
Thanks again, Nicandra. On today's episode, we also check in with a number of featured centers, programs, and initiatives working toward our theme of decarbonization. But first, back to Nicandra for the first of our interviews.
Well, we are welcoming our incoming AGU president, Lisa Grimlick. Welcome.
Thank you.
Now, giving a little bit of background, you are a professor at the University of Washington. A lot of your study in paleoclimatology. Yep. And you're just really excited about taking over this role, are you?
Oh, I can't tell you how excited I am. So there's an interesting backstory here. I was merely a board member, and we started to develop a strategic plan. And at one point I said, we really need to do science that is not just usable, but used. And all of a sudden that became sort of this rallying cry for the strategic plan. And so then the opportunity came to run for election as president that will be implementing that strategic vision. I ran and I won, and I couldn't be more thrilled.
And we talked about this a little bit off camera before. You're saying that's one of the things you're most excited about is really looking at the applied science.
Absolutely. Now, I need to say, AGU is over 100 years old, and we have been doing applied science. You're a broadcast meteorologist. When you give a forecast, it's something that somebody makes a decision on. That has always been a way in which we have made sure that we had value to society. We've got environmental issues that have become more complex. You think about climate change, and so the communication and the science has gotten even more difficult than merely the forecast of the weather for tomorrow. And so that's where we're really seeking to make the investment in how we actually communicate the science, and then what are we going to do about it?
And that leads us to today's topic is about looking at the climate change within our current time period. Your work looks at paleoclimatology. That's translating into getting us the knowledge we need to know how do we find the solutions.
Well, it was really only in kind of the mid-20th century that we started to have good weather and meteorologic records. So when we have an extreme event, is that normal or is that not? Because if I were to say to you as a taxpayer, you need to change your life, you need to invest in something because we believe climate change is happening. If we couldn't say that it's due to humans versus natural variability, I had no business as a scientist telling you, that you should change.
And it's so interesting that you say that because I think a lot of people use the word believe when they talk about climate change.
Yeah, you know what they do, and it's it tears me up and it makes me want to scream, but I've learned how to communicate more professionally and always like to suggest, well, can we unpack that a little bit and talk about why the science really is not about partisanship and it's not about ideology. And I talk about, for me, I was skeptical. I was a skeptic. I felt like I needed to answer that question. Is this natural variability or is this climate change? And to bring my best possible scientific tools, not just of myself, but of scientists from around the world, that we could assemble the data to look someone in the eye and say, no, there's evidence here. There's robust evidence.
And now you're here at the helm and, able to work on that messaging as one.
Absolutely. But it's funny because you say I'm at the helm, and one of the things I love about AGU, I always sort of quietly say, the team science is kind of a thing now. We are just like the teamiest of the team science. And it's not just the scientists, but it's the scientists and the staff and sort of our donors and our community members that really are that team of AGU that is making this strategic plan come to life.
Oh, thank you so much, Lisa. I know you've got a lot more that you're going to get a chance to enjoy at the conference and everyone else out there. So really great talking to you and meeting with you today.
Thank you for what you do. You too. Take care.
The Ecology Center at Utah State University is home to a new interdisciplinary graduate specialization in climate adaptation science. The CAS program is organized around an interdisciplinary team research project. Let's take a look at how they focus on doing science that matters. The Ecology Center at Utah State University is a long-running interdisciplinary center that fosters research in all things ecological. It also offers graduate Master of Science and PhD degrees in 3 colleges across USU. The Ecology Center unites a community of scientists with common interests in ecology and many different specializations. The Ecology Center is also home to a new interdisciplinary graduate specialization in climate adaptation science. The CAS program is organized around an interdisciplinary team research project, includes an internship beyond academia, and is available to students in 10 departments.
There are 3 things really that attract students to our programs. One is the desire to do science that helps people, science that matters to people, the internships they do, and the third thing is the interdisciplinary teamwork.
AGU TV is brought to you from the 2021 AGU Fall Meeting. You can find us in person at the Convention Center in New Orleans, in select hotels, as well as on the homepage of the meeting platform and online. From award winners to research center visits, it's all on AGU TV.
And now we're welcoming Christine Shields from the National Center for Atmospheric Research. Christine, thank you for joining us.
Thank you. It's great to be here.
Now, today's theme is climate change in the Anthropocene. Can you tell us about your work and specifically the Community Earth System model?
I am a project scientist at NCAR, which is the National Center for Atmospheric Research, and I actually work in the Climate and Global Dynamics Lab. And in this lab, we actually do a lot of climate change research. In my group in particular, we look at climate change and climate variability. And so a lot of what I do is I use models, Earth system models like the CESM, which is the Community Earth System model, as well as other global climate models such as the E3SM, which is the Energy Exascale Earth System model, and that's the DOE model. And I use these global climate system models to look at Earth's climate and its variability.
And why is it important to focus on the hydrological cycle in the past? How does that help us model the future?
One of the things that I do in my group is I look at the hydrological cycle, and I specifically look at things like atmospheric rivers, extratropical cyclones, and in my past work, I've actually looked at atmospheric rivers in deep time paleoclimate. And what this is, deep time is a time in Earth's history where the land masses were in different locations. And so I've in particular look at warm deep climates, and I've looked at atmospheric rivers in these warm deep climates. And One of the things about looking at these type of phenomena in a deep, warm climate is we can study things like climate dynamics, how the different components of the Earth interact with one another. And we can use that information to try to understand how these things and these climate dynamic relationships may change in the future.
You also work with new climate scientists to educate on the art of climate modeling. Do you have any tips or suggestions for, say, an undergraduate student that wants to get into the field?
So in addition to looking at things like math and physics, I would also study computer programming, and because it's actually, as a climate scientist and one that looks and uses climate models, understanding how to code in different programming languages is actually very valuable and important. The other thing I would recommend is actually to look up from the screen every once in a while. Connecting the real world to the simulated world is actually very important in order for us to develop models that are realistic. So I would definitely encourage people to pay attention to observations as well.
And what are you most excited for at AGU this year?
I am looking forward to listening to sessions that have to do with the global climate change. Right now I'm doing a lot of research actually on Antarctic atmospheric rivers, and so I'm actually looking forward to those the cryosphere and the atmosphere cryosphere interaction sessions as well.
Thank you so much, Christine.
Thank you very much for having me.
When it comes to confronting climate change, the Devacha Center for Climate Change at the Indian Institute of Science is focused on 3 principles: research, outreach, and policy. Let's see how they frequently engage in outreach activities to create awareness among people and policymakers about their climate change research and its consequences.
The Devacha Center for Climate Change was started in January 2009. Most of the work we do is interdisciplinary in nature, whether we look at the impact of climate change on monsoon, water security, and impact of climate change on health. And the major impact it has had is in creating awareness among the public and the policymakers about the urgent requirement to mitigate climate change.
The Devacha Center works in various areas of climate policy. Decarbonization is an important research theme. Colleagues are studying ways to decarbonize various sectors of the economy in India, as well as policy options that will likely help pave the way to a low-carbon transition. We've also been studying the renewable energy sector and its role in decarbonizing the electricity sector.
The center has established the South Asia Regional Office of Future Earth, which is a global science-cum-policy initiative. As a result, we will pursue region-specific, solutions-oriented research in collaboration with the government and other partners. Understanding of the complex water, energy, food nexus will be one of our main goals for the near future.
This year's fall meeting is unlike any other, as organizers have pivoted in the face of the pandemic to bring about a hybrid meeting of in-person and virtual keynote speakers, plenary sessions, and breakout meetings. So we are asking you, if you could convene any session on any topic at the fall meeting, what would it be and why?
The relationship between people and the science, that's something we can do much more about. I think that's my hair is getting grayer, this is this kind of things that I start to realize that there's a huge demand of sharing our knowledge, and I think this is something we can do much more.
Especially as an undergraduate and one of the younger attendees of this conference, I'd be really interested in kind of being able to create a session that allows us to better understand how we can connect the main messages of this conference related to climate change and kind of activism with people who don't necessarily align with those values. I've had to do this quite a bit with people back home, and so I'd be really excited to kind of both learn from other people who have gone through that same journey, while also being able to kind of give my own perspective about how you're able to kind of convince people that the science that we're doing and the effects of global warming are very real issues, and that they're worth addressing.
I think at the AGU we are covering almost everything. I'm always overwhelmed to almost run from a session to the other at the AGU, but that's the fun of it. I just enjoy it.
And we're back with Richard Moss from the Joint Global Change Research Institute. Richard, thank you for joining us.
It's a pleasure to be here. Thanks for inviting me.
Today's theme is climate change in the Anthropocene. Can you tell our audience just a little bit more about your work in this field over the years?
Yeah, so I've had a really fascinating, at least to me, career. I really enjoyed it. I've worked at the, what I'd call the science policy interface. So I've had some government positions and some research positions. But in my research career, I focused a lot on scenarios, both climate and other uncertainty characterization, what I'd call adaptive management, which involves using science to make decisions as we get better information, changing those decisions, and then a new field called multi-sector dynamics.
So now working in this space, I'm sure you've seen the field go from niche to one of the biggest topics of interest in Earth and space sciences. Can you talk a little bit about how you've seen that field change?
Oh, it's been so exciting to watch the field change. I mean, we started from a position in the 1990s where we'd release a major report with really important findings, IPCC or other, and we'd be lucky to get a little paragraph on page A5. And, there was also a lot of, early on, there were periods of negative attention, various campaigns that would be launched by interests that were threatened by climate change, raising questions about the science. And, over the years, it's just gone mainstream. It's exciting to see the mainstream interest shift from is climate changing to something that's much more about solutions.
So what aspects do you think have contributed to its growth? Is it public interest, better science, or something different?
I think a major factor is people's lived experience. We've always said that when people can see it with their own eyes, they're gonna become believers, and unfortunately, that's exactly what's happened. I'd also say that there is better science, and I think that we've done a better job of making science relevant to what people care about. And I'd point particularly to things like improved approaches for applying information that we know has uncertainty in decision making.
Are there any highlights from this year's AGU meeting that you would like to look at?
Well, the fact that the whole theme of the meeting is science and society, or science is society. I mean, I just think that is, it's just so exciting for someone like me that's been at the science policy interface to see that happening. And the second, I mentioned this multi-sector dynamics within the global environmental change section. And that's a really new transdisciplinary research area, meaning that it's combining both science and society.
If you had one message for upcoming climate scientists about the future of the field, what would it be?
Building on the theme of this year's meeting, I think that science and society are both better off when we collaborate. Your own science is going to be improved by seeing data through multiple vantage points. And I think that that's something when you're collaborating with people in society, you're kind of pushed to solve challenges that are more relevant to people and that they're more engaged in. We're in the right space here. It's exciting.
Thank you so much, Richard, for joining us.
It's really been a pleasure. Again, thanks for inviting me.
When it comes to turning the tide on climate change, Planetary Hydrogen has a plan to remove a gigaton of carbon from the atmosphere each year. How so? By utilizing their innovative ocean air capture system. Let's see how it works.
That's huge. A gigaton's a billion tons of CO2.
Our approach is called Ocean Alkalinity Enhancement. Sounds complicated, it's not. What we essentially do is add a light base to the surface of the ocean to counteract that acidity and allow the oceans to absorb more carbon.
This is a potentially game-changing technology. It employs elements and energy that actually are very abundant on the Earth.
From a chemist's perspective and a chemical oceanographer's perspective, I think it's an intriguing idea that is really worth studying.
We're a team of innovators, and I think we are people that find fun in solving problems.
We are back in the studio with Joe Hamman. He is an engineer and a climate scientist with the National Center for Atmospheric Research. He also is the technology director for CarbonPlan. And we are going to be talking about how your work plays into some of what we're learning about with climate science and really getting a lot more people involved in looking at that carbon footprint.
I work at both the National Center for Atmospheric Research, where I'm a scientist there, and I'm also the technology director, like you said, at CarbonPlan. At CarbonPlan, what we do is really trying to bridge the gap between climate policy and climate science. And we do that with a really cool team of technologists, engineers, research scientists, and also policy folks that work on a wide range of climate policy issues.
Tell us just a little bit more about how CarbonPlan works.
We're a nonprofit based in California, and we started right at the beginning of the pandemic in March of 2020. And our goal is really to elevate quality climate solutions and to help accelerate their deployment to help address the climate problem. So we do that through a range of kind of deep dive research activities and public-facing media pieces that tend to look a lot like interactive data visualization and storytelling around the kind of present-day best available science for various climate solutions.
Tell us how you personally got interested in this.
I worked for a few years in civil engineering and eventually ended up going to graduate school to study climate science and worked on climate models and a range of data science problems. And as I was working on various climate impacts issues, I found I really wanted to be working on more direct climate solutions. A couple years ago, had an opportunity to start CarbonPlan with a few other folks. We're trying to really turn the issue around and work more on direct solutions and use the best available science to push solutions forward.
And that's been a theme here with the meeting is talking about how to get those solutions out and working with different segments of society, not just in the scientific community.
One of the really cool things we've been able to do at CarbonPlan over the last couple of years is to take a look at some enacted policies and to take a step back and ask how well is that program working and take a look at some specific aspects, in our case, the forest offsets program, and ask some questions about whether or not that's working as well as we thought and how it might be improved going forward.
So for members that may want to get involved in this segment, what would you suggest?
If you work in a climate field or in a climate adjacent field, there's very likely an opportunity for you to get involved in one way or another. And I think one of the most powerful ways that I've seen folks get involved is to work across domains and to find folks that are working in adjacent domains that might be able to utilize your expertise. If you're an engineer, go find a lawyer that's working on climate risk issues and try to find a way to work with them. If you're a climate scientist, reach out to journalists or other people that are working on public communication and try to get your work out in a different way.
All right, well, thank you so much, Joe, for joining us today. We're going to have much more as we go on through the afternoon.
From air to land now, Sandia's geothermal research program is focusing on climate change security by harnessing the power of geothermal energy. This intense, abundant resource could heat and power homes and factories with a reliable, renewable baseload power if only we can overcome some significant challenges to extracting it. Let's see how Sandia is doing it.
Climate change is driving a set of very important environmental impacts. That's well established by the science now.
So Sandia has worked in the geosciences for over 50 years. As a national lab, it is focused on research and development that industry can't do.
We create the expertise that we have developed through different programs and really capitalize them and use them for geothermal technology development.
Sandia Geothermal Department fashions itself as a place to go to for harsh access in subsurface environments.
The area that we can contribute the most is really about accessing and understanding what the subsurface looks like.
And one of the things that was part of Sandia's effort was to develop the test capability to validate and verify the performance of the percussive hammers at high temperature. The idea behind the microhull is that it's cheap, it's fast, it's easily mobilizable, and one of the things that we wanted to do is try to expand the capabilities of microhulls to geothermal.
Transitioning to clean energy sources is critical. Geothermal will play a big role going forward.
Some really great work there from everyone on today's episode. That's all from us at AGU TV for today, but we are back again tomorrow for day 4 of AGU's fall meeting. On tomorrow's episode, we dive into diversity, equity, and inclusion in the sciences, and particularly what AGU is doing for the Earth and space science community. Nikandra, who will you be talking to tomorrow?
Atria, we've got much more exciting content for you. We're going to be joined by another great group of guests, including AGU Diversity and Inclusion Advisory Committee Chair, Lisa White. Sierra Green also joins us virtually with some insight into how scientists can learn from Native American traditional ecological knowledge. It is going to be a great show, so make sure to tune in.
Thanks, Nikandra, and don't forget, you can watch AGU TV anytime on the meeting app and platform, in select hotels, as well as online. Thanks so much for joining us. We'll see you back here again tomorrow.